ladies and gentlemen. Welcome to my lectures on electrical engineering. I'm Dr. Vijay Singh, and I'm a London-based educator and consultant. Today, I'll be taking on the basics of electrical engineering, electricity, and magnetism. I'm going to start with Kirchhoff's law. That's the very first rule that you need to know. So let's directly start with the topic. So this is Kirchhoff's law. So what is Kirchhoff's law and why do you need to study Kirchhoff's law? Well, before this, you have studied Ohm's law. Now, as far as Ohm's law is concerned, if you have one resistor and one battery, it's perfectly fine. You can use Ohm's law to solve the circuit. But the question becomes complicated as you attend the degree classes where you have multiple batteries, multiple resistors. And when you have multiple batteries and multiple resistors, that's when you need to use the Kirchhoff's law to solve these questions. So let's understand some basic terms on Kirchhoff's law. So what is a junction? So let's start with a junction here. So let's look at these red dots here. These red dots, so these represent the junction, or sometimes also referred as the node. Now, what is a junction? A junction is a point in the circuit. If you look at the circuit, this is the point in the circuit where three or more wires are connected together. So that's what is a junction. So you need to know what is a junction. I will be referring the word junction quite often while solving numerical problems. So you need to know that junction is a point where three or more wires are connected together. Then let's understand what is a branch. So this whole thing is considered as a branch. So let me display with my green dotted lines. So you have this as a branch. So a branch is all the wire and the components. You see all the wire. If you look here, all the wire and the components that are connecting one junction to another. So that's connecting one junction to another. So this is one branch. This is connecting one junction to another. And then what is a loop? So if you were to understand what is a loop, this entire thing is called the loop. So if I were to display this, this is called a loop. So many times while solving numerical problems, I'll be simply referring what is a loop, or I'll be taking loop 1 and loop 2. I want you guys to understand and know what is a loop, know what is a branch, know what is a junction. As I told you, sometimes in some British and American books, you will find junction as node. So don't get confused. Junction is the node. All right. Now, what are the two important laws of Kirchhoff? So Kirchhoff gave two important laws. The second one is the most important one. Majority of the times, we will be using the second law to solve numerical problems. The first law, it's an important law. You need to know it. But majority of the times, the first law will be embedded in a question which involves the understanding of the second law. So what is the first law? The first law states that the algebraic sum of currents, meeting at a point in an electrical circuit is 0. So you have an electrical circuit, and the sum of the currents entering and leaving the circuit is always 0. So you need to know that the algebraic sum of currents leaving or entering a circuit is always 0. Now, what's the second law? The second law is the most important one, and that states that in any closed part of an electrical circuit, just like the previous one we saw this, and any closed part of the electrical circuit, the algebraic sum of EMFs, the electromotive force, remember that electromotive force, that's the voltage, and you need to know the difference between EMF and terminal voltage. Make sure, guys, note down the difference between EMF and terminal voltage. That's the thing I'm going to ask you in my next lecture. So the algebraic sum of EMFs, right now you can understand EMF is just the voltage. So algebraic sum of EMFs is equal to the algebraic sum of products of the resistance and the currents flowing through them. Just to give you a hint, what is EMF? It is the voltage of the battery when no current is flowing in the circuit. So technically, if you have a battery and you just connect it to the voltmeter, the voltage that you get, that's the EMF. And what is terminal voltage? If you are drawing current from the battery and still you are measuring the voltage, so technically there is a resistance involved and still you are measuring the voltage, that is the terminal voltage. So second law states that in any closed part of an electrical circuit, so if you have any closed part of an electrical circuit, the algebraic sum of EMFs is equal to the current multiplied by the resistance. As you see, algebraic sum of the EMFs is equal to the algebraic sum of the product of the resistance and the current flowing through it. And this is called loop rule. So I have my first numerical problem here. This question was asked in IB physics exam, has been asked in some British universities as well as in British Olympia. So let's try solving this question. Look at this question. You have two batteries, 9 volt, 12 volt. You have 3 resistors, 3 ohms, 2 ohms, and 6 ohms. And they want you to calculate what is the current flowing in the circuit. Pause the video and try solving this question. And within minutes, I will be going over the detailed solution of this question. The reason why I chose this question, because if you understand this question, you will be able to solve any question related to Kirchhoff's law. This is one question that gives you a thorough understanding of Kirchhoff's law. All right, now let's go to the solution of this question. Let me share my screen, iPad screen. So all right. So I assume I gave you sufficient time to work on this question. So let's try to understanding this question. Now we start from here. Let's say this is the 9 volt battery. This is the 9 volt battery, and we start from here. Now I start from this part. This is the negative terminal of the battery, and this is the positive terminal of the battery. And let's imagine that a current I1 is flowing from here. So let's consider this as loop number 1. This is loop number 1, and a current I1 is flowing through here. Now, as this current I1, so always remember that you start from here. So this is the negative terminal of the battery, and this is the positive terminal of the battery. So the moment you go from negative to positive, there is a step up in the voltage. So this is going to be positive 9. So I'm going to write here positive 9. So I'm going to write the equation for the first loop. So try to understand how I write the equation. I start my journey from here. This is negative. And as I go from negative to positive, there is an increase in voltage. So if there is an increase in voltage, I'm going to write positive 9. And let's say current I1 flows here. And as the current I1 flows through this resistor, that's a 3 ohm resistor. I think the ohm part is missing here, but that's a printing error. So this is a 3 ohm resistor. Now, as the current flows through this 3 ohm resistor, there is a drop in the voltage. So the voltage falls. So I would say, and you know, voltage is current times resistance. So I1 times R, which is 3 times I1. Now, so this is negative 3 times I1 because there's a drop in voltage. Now this current goes here. As this current goes here, this I1 current goes here. But if you look closely, you will realize that I2 current is also entering here. You see, I2 starts its journey from 12 volt, goes through the 2 ohm resistor, and eventually enters through the 6 ohm resistor. Now, at point X, this is the junction X, where I1 and I2 combine together. Now, since I1 and I2 combine together, the current flowing through this resistor is actually I1 plus I2. But again, as the current is going in this direction, there is a drop in voltage. Why? Because this resistor is trying to take away the voltage. It eats away, or you can say eats away the voltage. Now, because it eats away the voltage, there is a drop in voltage. So you could say, again, using the formula V equals to IR, R is 6, and I is I1 plus I2. So you get negative 6 I1 plus I2, and that is equal to 0. Now you solve this equation. So try to rearrange this, and you have 9 minus 3I1 minus 6I1 minus 6I2, that equals to 0. Then you have 9 minus 3I1 minus 6I2 is again equal to 0. or you get an equation 9I1 plus 6I2 is equal to 0. That's your equation number 1. Kindly note this equation. You have equation number 1 ready here. Now let's talk about equation number 2. Again, do the same thing for loop number 2. When you're talking about loop number 2, you start from here. You're starting from the negative 12. And as you go up, there is a step up. So it's like you're going from negative to positive. So there is a jump in the voltage in positive direction. So you could say this is positive 12 volts. So I start with positive 12 volts. But as the current I2 enters the 2 ohm, the 2 ohm resistor eats away the voltage. So you could say negative 2I2 because there's a voltage drop here because it takes away the voltage. So it is negative 2I2. And now again here, you have the current entering is I1 plus I2. So you can say negative 6I1 plus I2, the same logic because the current is entering here. So there's a drop in the voltage. So that will be negative 6I1 plus I2, and that equals to 0. Rearrange this equation. And when you rearrange this equation, you get another equation, which is 6I1 plus 8I2 is equal to 0. So I have got my two equations, 9I1 plus 6I2 equals to 0. 6I1 plus 8I2 is equal to 0. Now what I'm going to do is, because in your exams, you are allowed to use the graphing calculator, I'm going to graph these two functions. And if you see, I've taken the screenshot of my graph. I graphed both the functions on my calculator, and I see the point of intersection. This is the point of intersection. And if you look at the point of intersection is 0 and 1.5. So my I1 is 0 and I2 is 1.5. And that's how we solve this question. Well, this question is an important question, but if you understand the concept, you will be able to solve this question and similar questions. So let's take up another question. And this time, what I'm going to do is I'm going to introduce more than one battery. So let's take another battery here. So let's talk about this question. This is problem number 17. This is from the Cambridge book. So consider the circuit diagram or circuit zone in which the batteries are assumed to have negligible internal resistance. The batteries, they do have negligible internal resistance because if you are talking about the internal resistance of the battery, you will have to include the voltage drop in the battery as well. But right now, we are not assuming that these batteries do have internal resistance. So we can directly start solving the questions. So I would advise you to pause the video for a moment, reflect on this question, try solving it, and then you can review my solution. So let's start working on this. Again, just like in the last question, I will be dividing the entire circuit into two loops. I have loop 1 and I have loop 2. So start with loop 1. Relax and just start with loop 1. Apply the rule in loop 1. So when you apply the rule in loop 1, you start from here. This is negative and this is positive. So what happens? Current starts entering. So you are going from negative to positive. There is a step up in voltage. So that's positive 2. This is positive 2. As the current is flowing, this is a drop in voltage because the 4 ohm resistor actually eats away the voltage. So there is a drop in voltage. And what is the drop in voltage? The drop in voltage is 4I1. Based on Ohm's law, V is equal to IR. So this is 4I1. So this is negative 4I1. And then the current enters here. Now here the current, as the current I1 enters here, you will realize that there's a current I2 entering from here. And at junction A, I1 and I2 combine together and they both go together as a unit. Now, if I were to calculate what is the voltage drop across 4 ohm, I would have to say minus 4 times I1 plus I2. And then look here, as the current is entering here, as you're moving here, at this point, you're going from a positive to negative. This is the positive terminal of the battery, and this is the negative terminal of the battery. So there is a voltage drop. So that's negative 4. Now rearrange the equation. 2 minus 4I1 minus 4I1, solve this. Minus 4I2 minus 4 equals to 0. And you get an equation 8I1 minus 4I2 is equal to negative 2. That's your first equation for loop number 1. Let's try to understand what happens in loop number 2. Now, again, in loop number 2, you're starting from 4 volts, a current I2 enters. Now, as this current I2 goes up, you can start with, you are going from negative to positive. So here, this is the negative terminal and this is the positive terminal. You're going from negative to positive. So there is a step up in the voltage. So that's positive 4. And then I2 is entering this resistor, 4 ohm resistor. So that there's a drop in the voltage. So it is negative 4 I2. And similarly, as the current enters in the middle part, I1 and I2 were combined together. So it will be I1 plus I2 multiplied by 4, but there is a drop in voltage. So that would be negative 4 I1 plus I2. And again, sorry, negative 4 I1 plus I2. And again, you see there is a drop in the voltage in the battery because you're going from positive to negative, and that becomes negative 4. So you have this equation now. And what you could do here, you could rewrite and rearrange this equation, and you will get 4I1 plus minus 8I2 is equal to 0. Now, this is my equation 1. 8I1 minus 4I2 is equal to negative 2. I have 4I1 minus 8I2 is equal to 0. Now, you can use your graphing calculator, sub in the numbers, and this is the screenshot from my graphing calculator. You see, my point of intersection is negative 0.333. So my current I1 is negative 0.34 amperes. I've just rounded it up. And for I2, it is 0.17, again, rounded it up. This means that, now here you see, we actually took the current in loop 1 as clockwise and the current in loop 2 as anti-clockwise. So if we are getting I1 as negative, that means the direction of the current is opposite to the direction what we had assumed. So we had assumed it in clockwise, but we are actually getting the current direction anti-clockwise. So this means that the current in the left cell, which one is the left cell? This is your left cell. This means that the current in your left cell is downwards, and the current in your left cell is downward, and the current in your right cell is upward. So this one, this is right cell actually. So right cell is upward. So the current in the left cell is downward. You see here, the current in the left cell is downward because I1 is negative. You got I1 negative and I2 is positive. All right, and you had one more question. What is the potential difference in between? So you can just use the formula V minus IR, and you get the potential difference in between as 3.3 volts. So that's all from me regarding Kirchhoff's law. Have fun solving these questions on Kirchhoff's law, and watch out my next video on more numerical problems on electrical engineering and Kirchhoff's law. Have a lovely evening and see you in my next video.